Welcome to Goobertown Hobbies. My name is Brent. There are 4 basic types of material that miniatures are made from. We're going to a factory and behind the scenes to learn about all of them. We'll make this pair of goblins in 4 different ways. We'll compare the results, and we'll compare each of the manufacturing processes. We're going to get deep into the pros and cons of each of these materials. All of this is happening at Trenchworx in Salt Lake City. I took a road trip with my buddy Casey from eBay Miniature Rescues, and we spent 2 days at the factory learning about how models are made.
Hello, my name is David Baker, and I own Trenchworx. And at Trenchworx, we make a lot of different models, as you can see. We work for a lot of people, and we build their models and ship them around the world. And we also build our own models, which are tanks and dragons and other things that we have in partnership with many of our great customers.
One of the fascinating things about Trenchworx is the sheer variety of models that they produce. To do this, on a daily basis, they use all 4 of the production techniques that we're gonna talk about. Each of these materials has advantages and disadvantages. None of them is dominant and none of them is obsolete. It all depends on the design of the model, the size of the order, and the preference of the customer. Okay, these are the 4 types of material: photopolymer resin, 2-part mixing resin, thermoplastic, and metal. These days, most sculptors are working digitally. No matter what materials the minis will ultimately be made of, the physical masters are usually made with a 3D printer. Layer by layer, these printers polymerize the acrylate moieties from the liquid resin into a solid. Ultraviolet light from a pixel on the screen underneath the vat of resin will initiate a radical chain reaction which polymerizes a voxel worth of resin. Printing a plate of miniatures takes a few hours, after which the miniatures are removed from the printer, washed 3 times in isopropyl alcohol, dried, and then given a final cure with a bit more UV light. High-resolution 3D printing is used to make masters, and it's also becoming common for the production of miniatures that are sold directly to consumers. 3D printing has come a long way. A decade ago, Trenchworx was using exotic printers that cost tens of thousands of dollars. These days, though, many consumer-grade printers are up to the task. With professional operators and an efficient workflow, minis can be manufactured with these mass-market 3D printers. The highest resolution printer in the fleet is used to make the masters, and the masters are used to make the molds for the other materials. The team uses scalpels and sandpaper to clean up the masters.
Hi, I'm Ansley. I work here at Trenchworx. So I clean a lot of the masters. I clean them up and make sure that if I were to get it, I wouldn't be upset. That's kind of our golden rule here. We all love the miniature hobby. We've all had experience with working on figurines. And yeah, if it looks good, awesome. If you're like, this could look a little better, throw it away, start again. We want to make sure people get good stuff.
Every detail and every defect on these masters is going to get copied over and over and over, so now's the time to get them looking good. In the plastics industry, resin is a broad term. In addition to 3D printing resin, which is a photopolymer, there's also 2-part casting resin. 2 liquid components are mixed together and poured into a mold. Epoxide chemistry will link things together, and the liquid will cure into a solid. To make resin minis, the mold is made out of silicone. The masters are attached to a sprue, and these L-shaped brackets are used to build an appropriate-sized box. Liquid silicone is weighed out and mixed with activator. The mixture is placed in a vacuum chamber, and the vacuum is used to remove gas bubbles. There can be a lot of gas bubbles in there. The liquid silicone is poured around the masters, and then the frame is moved to a warm room for curing. After 24 hours, the silicone has cured and the molds can be finished. The silicone is a soft, flexible solid now. The box frame is removed, and a sharp scalpel is used to cut the mold open. The cuts are deep enough so that the silicone can be opened up and the masters can be removed. The cut has a bit of a wavy shape to help keep the mold nicely aligned.
Hello, my name's Gavin. This is our resin casting area. So we have multiple pots that we cast in. For resin, we have our pump station over here. We pump out the resin. We'll do a quick stir, put it in the pots, let it vacuum for about 2 to 3 minutes, and then we'll put a pressure onto it right after that, and it'll sit in the pots for about 30 minutes, and then I'll crack it, and then let the pressure out, and then pull them out and demold the molds.
For casting, the mold is placed into a pressure pot, and it's not going to move until the resin has solidified. The resin is a two-part mixture. Equal measures of parts A and B are pumped into a cup, mixed, and then poured into the mold. Those big slots funnel right into the sprue and down into the cavities for each of the bits. A lid with a vacuum hose is attached, and the air bubbles are pumped out of the resin. Again, there can be a lot of air in there. After this, the lid is switched to pressurize the pot to prevent any new air pockets from forming while the resin is curing. It takes about an hour or two for the resin to fully cure, but after 30 minutes, the resin is solid enough to be removed from the mold, and the mold can be used again. These soft silicone molds give incredible detail, but they start to degrade after about 20 uses. The team clips a notch onto each mold after each use, so that they can tell when it's time to retire it and make a fresh one. There's always a bit of excess resin at the top of the mold where it funnels down into the sprue. This solid reservoir gets chopped off and thrown away, and then the sprue is ready to be packaged and sold. Next up, metal. Blocks of pewter are melted down and cast into miniatures. This liquid metal is somewhere around 500 degrees Fahrenheit. The alloy in there is about 95% tin, with the remainder composed mostly of antimony and copper. A ladle of liquid is poured into the spinning mold. Centripetal force fills the cavities. The molten metal cools into a solid, and you've got yourself some nice pewter miniatures. To make the molds, the 3D printed masters are dipped in mold release. While they're drying, a central hub is pressed into a circular slab of silicone. Next, the masters are carefully placed around the outer rim. In this phase, the silicone is soft. It can take impressions and be sculpted. Material can be added or removed to fine-tune the contours of the part line between the two halves of the mold. The mold maker needs to fill all the gaps around the model and avoid undercuts. They also do their best so that the seam line between the two halves of the mold is perpendicular to the master. Acorn nuts are the metal nubs which are added to one half of the mold to help it register and align with the other half. A layer of talcum powder is placed over the bottom half of the mold so that it doesn't fuse to the top half. Next, if any material needs to be added to the top half of the mold, this can be sculpted over the masters now that the talcum powder is covering the bottom half of the mold. These lumps are filling in gaps on the top side of the masters, and this material will fuse to the top of the mold during the vulcanization process. A second fresh round of soft silicone is placed on top of everything. This will become the other half of the mold. A steel cap is placed on top, and this layer cake of nascent silicone is taken to be vulcanized. Heat and pressure are applied to the mold. This is the vulcanization process, and it causes the shapes to become permanent. After a few hours, the silicone has become much harder, and it will retain the details of the imprints. When the mold cools a bit, the two halves are separated and the masters are removed. Sometimes the masters are destroyed in this process, but in this case a special 3D printer resin was used, which is able to survive the heat and pressure. With a scalpel, channels are cut so that liquid metal can flow from the central ring out to the cavities for each of the bits. Air vents are also cut. This cutting process requires experience. If some of the cavities don't work well at first, it may be possible to modify the channels in an iterative process until the whole mold is functional. After the mold has been cut, it's put into the spin caster. The entire thing spins around. Liquid metal is poured into the central hole, and centripetal force fills the cavities. The mold is left spinning for about 30 seconds, and then it's taken out. Within just a minute or two, everything is cool enough to pop the mold open and take out the minis. The metal sprue can be melted back down again and completely recycled. Look at these things. I think they're great. There is something strangely satisfying about metal minis. The fourth type of material is thermoplastic. This is solid plastic which is melted down and used for injection molding. In the world of models, there are three notable subtypes of thermoplastic. Trenchworx has a siocast machine. Actually, this is the exact same instrument that I filmed at Adepticon in Chicago a few years ago for my previous video about siocast. The siocast molds are very similar to the molds for metal spin casting. These are 2-part hard silicone molds that are made in almost exactly the same way. The biggest difference is the shape. For spin casting, the molds are round, and for siocast injection, the molds are rectangular. A vacuum pump sucks the air out of the molds, and then hot liquid plastic is injected. Each mold has a unique program stored in the instrument so that the right amount of material gets injected. Just like with metal spin casting, after a minute or two the mold is cool enough to be opened, and then the minis are ready to go. Sprues and miscasts can be ground up, melted down, and recycled. The thermoplastic used by the siocast machine is a polyamide, aka nylon. There are 2 other thermoplastics that are important in the world of models and miniatures. Polystyrene is the thermoplastic used by Warhammer and Gunpla and model airplanes. Polyvinyl chloride is the softer plastic used by Reaper Bones, WizKids, and board game minis. Polystyrene and PVC require expensive metal molds. They're great for high volume production, but for medium scale work, siocast is a better fit. If you're curious, I have a video all about polystyrene injection molding at Archon Studio. As for PVC, well, stay tuned. So to recap, I think it's fair to say that there are 6 materials that are used for the vast majority of models on the market. 3D printing, 2-part resin, pewter, siocast, polystyrene, and PVC. Polystyrene and PVC make sense if you're producing 10,000 miniatures, but for small and medium-sized runs, the other 4 techniques are more viable. There are hundreds of miniature companies in the world, and most of them are small businesses that only need to produce a modest number of copies of each miniature. Trenchworx specializes in this small-scale production. On a daily basis, they work with 4 different materials. It's fascinating to me that all 4 of these are viable. None of them are dominant, and none of them are obsolete. The material for each miniature is picked based on the project, and these folks have a wide variety of projects. They make 28mm figures and tanks for Victoria Miniatures. Trenchworx has their own line of tanks and their own line of modular orcs. They also have a series of crowdfunding campaigns for Matt Colville's MCDM RPG modules. At the time of our visit, they were packing up a box of MCDM goblins, and they were launching a backer kit campaign for MCDM hobgoblins and kobolds. Oh, and here are some gunslingers for Knuckle Duster miniatures. Here are some Guardian Gnomes for Tabletop Troubadour. While I was visiting, they were working on Warzone Eternal minis for Res Nova, and of course, they were working on these goblins for a little company called Goblin Hobbies. Trenchworx manufactures a wildly broad range of miniatures, all at modest scale. High mix and low volume. The only way this can be viable commercially is by being clever and efficient at every step along the line. Everything needs to be optimized. Something that ended up being just as interesting as model making was the setup of the factory. Dave is an engineer. It was clear to me that he takes pride in planning the workflow, designing the work areas, and building individual pieces of equipment. The factory is set up in a series of U-shaped work cells. These are like one-person assembly lines. When Gavin is working on the 3D printed models, he just needs to turn counterclockwise to take a model from the printers, to the washing station, to the drying station, to the curing station, and finally to the outbox trays of finished models. The metal work cell has a workbench, the hot pot of metal, the spin caster, and cooling racks all set up in a nice U. On the other side of that cooling rack is a similar setup for the siocast injection molding. A workbench, a booth to powder the minis with mold release, the injection molding instrument, and a cooling rack. The resin station has a workbench, the 2-component resin pump, and a line of pressure pots. The pressure pots for resin casting are all bolted down so that they can be opened and closed one-handed. Each pot will need 2 or 3 minutes of vacuum followed by about 30 minutes of pressure. So, the station has 1 lid plumbed to a vacuum line and 6 lids plumbed to a pressure line. At least half of the workstations in this factory are made out of this 80-20 T-slot aluminum. This material is awesome for making custom furniture and equipment. I love this stuff. Heck, I use T-slot aluminum back home in Goobertown to hold lights and cameras and monitors and microphones and backdrops and all that kind of stuff. It's nice to be able to customize your workspace and really get it dialed in for efficiency. There were a zillion clever little systems and bits of equipment. This pump gives the correct ratio of parts A and B for resin. This hose dispenses the correct ratio of parts A and B for silicone. These custom L brackets are used to make custom molds in the proper sizes. The flat bases for these even have little lips to make them easier to pick up off of a table. The systems for organization and communication are important too. The silicone molds are notched every time that they're used to know how much life they have left in them. The molds for siocast, metal, and resin are all organized and labeled so that they can be found when they're needed. Everything around here is color-coded. Masters for making new resin molds are cast in blue so that they're easy to find and they don't accidentally get sold. Miniatures for customers are normally made with gray. The buckets and trays are color-coded to know whether finished models are ready to be packaged or need some sorting, or maybe they're miscasts. In the center of the factory is a library of finished minis that are waiting to be sold. They keep a small stock of thousands of different SKUs for a variety of their customers that are packaged and ready to be shipped when they get an order. When they run out of a particular miniature or set of miniatures, there's a card in the empty bin that has a list of all of the bits that need to get manufactured. That card gets taken over to a Kanban system so that the employees know what needs to be made. All of these systems for letting people know what's going on and what needs to be done next are critical for making this a viable business. When choosing a material for a miniature, the considerations are the price of the materials, the cost of an employee's time, and the preferences of the customer. The team at Trenchworx showed me what was required to make this pair of goblins in 4 different materials. So now we're ready to dig down into the pros and cons. For visualization purposes, the material in these cups are the raw feedstock that are required to make 10 copies of the Elma Goblin. Alright, let's talk about costs. If everything is going smoothly, this goblin costs the factory about $2 to make in metal. That calculation includes materials and labor, but excludes some of the other overhead of operating a factory. Interestingly, metal requires the least labor, so most of the cost is in the price of pewter. The metals in the pewter alloy are commodities that are useful in electronics, and the prices wander around at the whims of the global market. Elma the Goblin has a big solid suitcase. At current prices, her suitcase alone uses about 75 cents worth of metal, and that adds up quick. The other 3 materials are cheaper. They each cost about $1 to make the same miniature, but they have different distributions of labor and material costs. Resin requires the most labor and uses the cheapest materials. 3D printing and siocast have moderate labor costs and moderate materials costs. Let's go deeper. 3D printing. No molds are required for this technique, so this is the fastest way to make prototypes and small batches of models. A digital file can be sent across the world instantly, and the first minis can be ready within a few hours. The cost per gram of 3D printing resin is moderate compared to the other materials. The team can choose different 3D printer resins with different properties depending on the job. There are no material costs for molds, but printing supports are required for most minis, and these are a form of solid waste. Liquid waste is also generated as the isopropyl alcohol, which is used to wash the prints, becomes saturated. In the factory, one limitation on 3D printing is space on print beds. It may take several hours to print a mini, so each printer only gets a handful of turnarounds per day, depending on the height of the print jobs. There's a decent amount of labor involved with cleaning the prints, curing them, and getting the printer turned around for another run. As for quality, there are no mold lines running down the center of the minis that need to be cleaned up. However, certain areas of the model may show layer lines from the printing process, and there may be nubs from the printing supports that need to be sanded down. The durability of these models varies based on which resin is used. Some are quite durable, while others can be a bit brittle. A unique feature of 3D prints is that they can have shapes that would be impossible to cast in other ways. You don't have to worry about undercuts. In general, 3D prints can have more complicated designs with fewer bits and less gluing. 3D printed models cannot be recycled. Any misprints are either trash or they go into a bargain bin for terrain and kit bashing. Next up, resin. Gram per gram, resin is the cheapest raw material on this list. Because of that, it's the best choice for big chunky models like dragons and buildings. The soft silicone molds are capable of some incredible detail, and the flexibility allows for designs with some slight undercuts. Unfortunately, these soft molds are only good for about 20 uses before they degrade and need to be retired, so a lot of material and labor goes into making fresh copies of each mold. Each resin pour is given about 35 minutes to cure in a pressure pot, so this curing time and the number of available pots and molds will limit the rate of production for resin miniatures. Resin miniatures can look really good though. It's easy to file down any defects, and these have moderate durability. 2-part resin is not recyclable. This technique generates sprues and the retired molds as waste. Any miscasts end up in the same bargain bin as the 3D prints. My buddy Casey spent a lot of time in this bargain bin. I took home a few things from this bin too. These Inquisitors from Victoria Miniatures aren't quite right, but I painted them anyway. I bet they weren't expecting that. Next up, metal. Pewter is relatively expensive. The material cost for pewter is substantial, higher than all of the other materials in this factory. The weight also makes shipping costs go up. On the plus side, once the molds are made, they last for many hundreds of casts. Metal casting is also a quick process. The limiting factor is giving the molds a minute or two to cool down between casts so they don't overheat. If an employee is working through a rotation of a couple of different molds, they can make thousands of miniatures per day. Metal is also nice because it's completely recyclable. The center spoke, miscasts, and even extras can be melted back down and made into something new. On the painting desk and the game table, metal is polarizing. Some folks love the classic feel of it, and some people really dislike the weight. Metal can be cleaned up pretty well with a file. Paint is more likely to chip off of metal than it is from any of the other materials. The weight of metal is way more than the weight of the plastic bases, so that raises the center of mass, and you're more likely to drop the metal minis. Also, when you're gluing metal minis together, the weight of some bits may require pinning so the joints don't fall apart. Even with all these disadvantages, there's something about metal that's just plain cool. A lot of people out there will always love their metal minis. Finally, let's talk about siocast thermoplastic. The hard silicone molds have a similar cost and lifespan to the molds used for metal miniatures. The nylon plastic from siocast has a moderate price per gram when compared to the other materials, but siocast still has a monopoly on this exact blend of nylon. The injection molding instrument itself costs tens of thousands of dollars and requires some special training and experience to keep it running properly. Once everything is set up, though, the speed of production is similar to that of metal casting. An employee using several molds in rotation can create more than 1,000 miniatures per day. Again, a limiting factor is the time for the liquid plastic and the mold itself to cool down after each injection. Models with smaller volumes can cool faster and are therefore slightly easier to make with this technique. Thermoplastic can be recycled. The sprues and miscast minis are put into a grinder. They get ground up into these flakes, and they can be poured back into the instrument to be melted down and used again. The plastic can degrade after a few melting cycles, so it's not infinitely recyclable in the way that pewter is. The waste from the factory is generally mixed with new pellets and reused. This injection molded material is reasonably durable, and the detail can be quite good. Unfortunately, it often doesn't sand or file well, so a sharp scalpel is the best way to slice off the mold lines. As you can see, these 4 materials all have different pros and cons. For some of the model kits sold by Trenchworx, different bits are made with different materials. For example, these sporks, or space orcs spelled with an X, use resin legs and torsos, and everything else is 3D printed. Some of the shapes of these bits can only be done with a 3D printer. The open mouths with all of those teeth have too many undercuts to come out of a mold. The barrels of the guns come pre-drilled, and that's nice too. Resin is used for the bulky bits because there's no risk of layer lines. Also, the thick cross-sections can stick to the FEP sheets of the printers and cause a higher rate of wear and tear. The MCDM Goblin Encounter box that I bought uses resin, siocast, and 3D prints depending on what material was the best fit for each part. The drawback to using multiple materials is an organizational and logistics cost. The correct number of each piece all need to be ready for packaging all at the same time. That's trickier to do when they're all made out of different materials. Historically, people don't like mixed material miniatures that include metal because of the weird distribution of weight. But for the other three materials, they can combine pretty well. Once the models are painted, it really doesn't matter how each part was manufactured. Now, a drawback to all four of these materials is that they do not work with plastic cement. Superglue is the best bet for gluing these miniatures together. Plastic glue only works on polystyrene miniatures, and these are only produced by larger companies with relatively big print runs. Still, all four of these materials can give models that look awesome and are a blast to paint. This factory works with a wide variety of clients, and some of them are extremely small businesses. I think it's great that small games and miniature companies can have access to physical miniatures. I always love discovering a new line of miniatures. At Trenchworx, I found some old favorites, but I also found some delightful things which were new to me. There's so much talent and creativity in this niche industry. It's great to see it brought to life with physical miniatures that you can touch and hold and paint. It was wonderful to see how all of this works. Please join me in thanking the folks at Trenchworx for letting Casey and I visit them behind the scenes. They were incredibly open with us about how they make models and why they do things in the way that they do. It's always a bit scary to let people wander into your back room with a video camera, so I want Trenchworx to know that we really value this collaboration. You can learn more about what they're up to from Trenchworx.com. This is where they sell their own miniatures and miniatures from some of their clients. They also have a series of crowdfunding campaigns. Alrighty, I think that'll do it for today. Let us know what questions you have about these processes in the comments, and as always, thanks so much for watching.